Welcome to another podcast. This episode, we're going to be taking a look at how to calculate limits that involve conjugates. We're going to try to also describe exactly what a conjugate is and why we use it sometimes, but other times we don't. Most of our discussion is going to be centered on this particular limit. So let me go ahead and write the limit up here. We're going to be looking at the limit as x goes to 1 of 2 minus the square root of 3 plus x divided by x minus 1. Now, in looking at this limit, the numerator term is of the form a minus the square root of b. Now, this is the term that basically tells you that you should be using this conjugate method. Now, in order to really sort of talk about what conjugates are and how we're going to use them, I actually want to create a list of conjugates that you should recognize and then what is the result upon multiplying by the conjugate. We're going to start with just creating a little table here. The table is going to have two parts. And so let's suppose that your original functions, this is like the a minus square root of b, is of the form, and I'll just use a minus square root of b for this. Then the conjugate of that is of the form a plus square root of b. Okay, so I need one more column to my table. And let me go ahead and extend this out a little bit. So the last column to my table here is the result upon multiplying these two. So if I take an expression and its conjugate and multiply them together, what is the result? Well, the result, so the result upon being multiplied here, is that a minus square root of b times a plus square root of b is equal to, if you do the FOIL operation here, you get, this is a difference of squares. So in a difference of squares, you always square the first term and square the last term. So it's a squared minus the square root of b squared. But the result of that is a squared minus b. So you can see here that the original thing we started with in the top is somewhat simplified. In fact, the radical is gone. Let's see if that holds true for other radical types. I could put a plus square root of b here, but that would just be the reverse of what we just did. So what if your term in the numerator or the denominator, these could also be in the denominator to start with, what if your term looked like this? Then its conjugate would be the square root of a plus b, and the multiplication of these two would give something like this. So somewhat similar, but once again, no square roots, no radicals are in the expression once the conjugate and the original function are multiplied. I could put the square root of a and the square root of b both in there, and let's add them this time. If I start with two terms added, then the conjugate of those two terms is then subtracted. That's how we form the conjugate, is by changing the addition to subtraction or vice versa. And then multiplying these two together, we get an honest to goodness difference of squares here that is kind of nice because it simplifies to just a minus b. And so if you ever get an expression of this form, you definitely want to use the conjugate because you can see the resulting expression is far simpler than the original one. Okay, finally for this last one, let's suppose that you just start with a minus b. So if I had a minus b, what's the conjugate of that? Well, the conjugate's a plus b. And if you do the multiplication, this is the difference of squares that you probably learned in high school. This factors into a squared, or not factors, but it expands into a squared minus b squared. So the question is, should I use the conjugate if I'm looking at something like a minus b? Well, the answer is probably no, and the reason why is you started with this, and after multiplying by the conjugate, you ended up with that. The expression that you ended up with is somewhat more complicated than the expression you started with. typically, we will only use the conjugate method with square roots because you can see in all three of these examples, if I take the original function and multiply by its conjugate, the result is something that's simpler because it doesn't involve radicals than the thing we began with. So the question here is, how do we carry this over to the limit for this problem? Well, rather than calculate the limit as is, which I can't do because I can't plug in x equal to 1 directly, I'm going to use this algebraic technique of multiplying by the conjugate. So what the technique involves is a fancy way of multiplying by 1. I think we understand in mathematics that if you multiply by 1, you're not going to change the expression. So I'm going to choose to multiply by 2 plus the square root of 3 plus x divided by 2 plus the square root of 3 plus x. Now, this is equal to 1. I multiplied by 1. I didn't change the original function or the limit involved. I simply multiplied by the conjugate of the numerator. So the numerator was of the form a minus square root of b. The conjugate is a plus square root of b. Multiplying the two gives a squared minus b. So the easy way I remember how to simplify expressions like this that involve the conjugate is to look at the first term, which is 2, square it, you get 4. Look at the second term, which is square root of 3 plus x. You square it, it gets rid of the square root, so you get 3 plus x. And then it's minus in between. If you notice, all of these have minus signs in them, and that's because you're multiplying a positive by a negative in each case. So you simply just square the first term and square the last term, and that's what our new numerator is. Now, the price you pay for this is the denominator gets more complicated. So this is now our new denominator. And at first, this doesn't seem like it accomplished anything because I've still got this x minus 1 term in the denominator that I can't cancel out yet. But the hope is that the algebraic trick that we used is actually going to get the top to somehow cancel with the bottom. And you can see here that the numerator does simplify nicely. 4 minus 3 is 1. And then minus x is negative x. And so if you then compare that with what we have in the denominator, all of a sudden you see a way forward in that I can rearrange the top. 1 minus x is the same thing as negative x minus 1. Right? If you just flip that, that's where the negative sign comes from. So flipping that requires you to multiply by a negative, which will then cancel with the denominator. And so this cancellation is nice. It's what we normally expect when we're working limit problems algebraically like this. And so we end up with the limit as x goes to 1 of negative 1 remains in the top. And in the bottom, I'm left with that conjugate that I multiplied by. And so now let's see if it has the direct substitution property. Can I plug in x equal to 1? And it turns out I can. If I plug that in, I get the square root of 3 plus 1. Now I still have the limit here, or I've taken the limit here, so notice I don't use the limit symbol out in front because I've done the limit when I plug in the 1. And I've got negative 1 over, let's see here, that's 2 plus the square root of 3 plus 1 is 4. So this is the square root of 4. Square root of 4 is 2. So this limit here is negative 1/4. And so the trick of multiplying by the conjugate is this very first step we did. And oftentimes what will happen is if you do it correctly, you'll get a cancellation to occur like we did here. Most of the problems are set up so that will occur. At the very least, it allows you to simplify something. Typically, we want our numerators to be less cluttered than our denominators, and so this is a much more preferable form to look at this fraction than is the original fraction itself. But the goal of this is to make something that was complicated simpler algebraically so that we can evaluate the limit. And essentially, there are 3 cases, right? If you look at these 3 cases here, those are the 3 cases that you need to keep an eye out for. Now, either of these 2 columns, it could be something of the form a plus square root of b, in which case its conjugate is a minus square root of b. Or if it's square root of a plus b, it could be square root of a minus b. But any of these 6 forms here you need to keep an eye out for in terms of using this trick of multiplying by the conjugate. All right, thank you for watching.